July 25, 1944, 23,000 feet above the Norman hedgerows, where morning mist clung to ancient stone walls like the breath of ghosts. The air inside the cockpit of Republic P-47D Thunderbolt serial number 4276504 carried the metallic tang of high-octane aviation fuel and the ozone scent that preceded thunderstorm. Below, threading through the maze of narrow French roads like silver serpents, German supply convoys moved with the confidence of an army that had never truly learned to fear the sky. Major Robert Johnson of the 61st Fighter Squadron adjusted his oxygen mask and felt the familiar vibration of the Pratt & Whitney R2800 double wasp engine beneath his boots. 18 cylinders, 2,800 cubic inches of displacement, generating 2,400 horsepower at full military power. The Thunderbolt was not graceful, it was not elegant, but it was honest in the way that sledgehammers are honest, in the way that industrial machinery carved from pure American resolve could be honest. The aircraft weighed 7 tons when fully loaded, more than twice the weight of its nimble British cousins, but that weight carried purpose. Each of the 850 caliber machine guns held 350 rounds. The underwing pylons could accommodate 2,000 pounds of ordnance, or 8 high-velocity aircraft rockets, each carrying a 10-pound warhead capable of penetrating 4 inches of armor plate. The radio crackled with the calm voice of Captain William Henderson, forward air controller with the 2nd Armored Division. Jug Leader, this is Sunray 7. Target convoy approximately 12 vehicles, moving northeast on road junction 7 kilometers south-southeast of St. Lo. Flak reported light to moderate. Weather ceiling dropping to 800 feet. Johnson keyed his microphone. Sunray 7. Jug Leader copies. Flight of 4 inbound, ETA 3 minutes. He glanced at his wingman, Lieutenant Charles Morrison, flying tight formation off his starboard wing. Morrison's aircraft carried the same lethal load, the same industrial confidence born from assembly lines in Farmingdale, Long Island, where Republic Aircraft Corporation workers had built this particular instrument of precision destruction during the graveyard shift in February 1924. But 800 feet below, Oberst Heinrich Kluge of the 276th Infantry Division Supply Command held different assumptions about American air power. Flying refrigerators, he had told his staff officers 3 weeks earlier during a briefing in a commandeered Norman farmhouse. The Americans build their fighters like they build their automobiles, heavy and crude. Our flak crews have been complaining about nuisance raids, but these are not the precision weapons of the Luftwaffe. They drop their bombs from high altitude and hope for luck. A properly dispersed convoy with adequate air defense can continue operations despite their theatrical displays. Kluge was a veteran of the Eastern Front, where German supply columns had learned to move at night, to spread their interval, to position their quad-mounted 20mm Flak 38 guns with overlapping fields of fire. His doctrine had been forged in the crucible of 3 years of war against Soviet aviation, where German logistics had survived through superior training, rapid movement, and the fundamental belief that motorized infantry convoy operations were too complex and too temporary for enemy air forces to interdict effectively. This morning, his conviction felt unshakable. Convoy Margaret consisted of 14 Wehrmacht transport vehicles, 8 Opel Blitz 3-ton trucks carrying artillery shells for the 352nd Artillery Regiment, 4 Mercedes-Benz L3000 fuel trucks loaded with 2,000 gallons of precious gasoline, and 2 ZKF Zelts, 7 half-tracks mounting Flak 38 guns. The convoy had departed Falaise at 00:30 hours under cover of darkness, following secondary roads through the hedgerow country, where Allied fighter bombers rarely ventured during daylight hours. Each vehicle maintained 50-meter interval. Radio discipline was absolute. The flak crews had been reinforced with veterans from the 3rd Flak Regiment, men who had survived the bomber streams over the Ruhr Valley. American pilots, Kluge observed to his aide, Hauptmann Franz Weber, as they watched the convoy from a concealed observation post, are trained for quantity, not quality. They attack in straight lines, from predictable altitude, with standard procedures. Our countermeasures have adapted accordingly. Weber nodded, studying the tactical map spread across a wooden ammunition crate. The meteorological reports indicate ceiling dropping below 1,000 feet within 2 hours. Even if enemy aircraft appear, visibility conditions will prevent accurate bombing. Neither German officer understood that they were observing not just a supply convoy, but the final movement of an industrial and technological evolution that had transformed American air power from a strategic concept into a tactical scalpel. The Republic P-47 Thunderbolt had emerged from Republic Aircraft Corporation's engineering team as a solution to specific performance requirements established by the United States Army Air Forces in 1940. The specification called for an interceptor capable of climbing to 35,000, carrying heavy armament and possessing sufficient range for bomber escort missions over occupied Europe. Alexander Kartveli, Republic's chief designer, had approached the challenge with the methodical precision of an engineer who understood that air combat was fundamentally a problem of applied physics. The resulting aircraft embodied mathematical brutality. The R-2800 engine delivered more raw power than any single-engine fighter in operational service, enabling the Thunderbolt to dive at speeds exceeding 500 miles per hour, while maintaining structural integrity through G-forces that would tear apart lighter design. The airframe could absorb battle that would destroy more delicate aircraft. But most importantly, the wing design and structural strength allowed the P-47 to carry external ordnance load that transformed it from an air superiority fighter into something unprecedented, a flying artillery piece. By July 1944, American industrial production had delivered over 5,000 Thunderbolt to combat units in the European theatre of operations. The 99th Tactical Air Command, under the leadership of Brigadier General Otto Weiland, had perfected the integration of close air support with ground operations through systematic analysis of combat effectiveness reports, pilot debriefings, and captured German documents that revealed the psychological and logistical impact of precision air attacks on enemy supply operations. The high-velocity aircraft rocket represented a technological breakthrough that had emerged from collaboration between civilian engineers, Navy ordnance specialists, and combat pilots who understood the limitations of conventional bombing against mobile targets. Each 5-inch rocket carried a warhead containing Composition B explosive, a mixture of RDX and TNT that generated a blast effect equivalent to a 75mm artillery shell. The rocket motor burned solid propellant for 1.2 seconds, accelerating the projectile to a velocity of 1,000 feet per second. At close range, trained pilots could achieve accuracy sufficient to engage individual vehicles. But the true revolution lay not in the weapons themselves, but in the tactical doctrine that had evolved from 18 months of continuous operations against German forces. Forward air controllers, equipped with radio communications and detailed maps, could direct fighter-bomber attacks with precision that eliminated the distinction between air and ground operations. Pilots no longer flew pre-planned missions against general target areas. They responded to real-time intelligence, adjusting their attacks based on immediate battlefield conditions, weather factors, and enemy defensive positions. This coordination between air and ground forces represented a fundamental shift in military thinking, one that German commanders, trained in the doctrine of separate service operations, failed to fully comprehend until the tactical consequences became irreversible. Major Johnson's flight descended through the cloud layer at 08:47 hours, emerging into visibility at 900 feet altitude. The Norman countryside spread below them like a vast tactical map, delineated by the geometric patterns of hedgerows, stone walls, and narrow roads that had channeled military movement since the armies of William the Conqueror. But Johnson's attention focused immediately on a line of dark vehicles moving northeast along a secondary road that paralleled the Via River. Jug flight, visual contact, convoy approximately 14 vehicles, mixed trucks and half-tracks, flak positions visible at head and tail of column. Sunray 7, can you confirm target identification? Henderson's voice came through the radio with the calm precision of an artillery officer. Jug leader, confirmed. Intelligence indicates ammunition and fuel supply for 352nd Artillery Regiment. Priority target. Weather window closing in 15 minutes. Johnson felt the familiar tightening in his stomach that preceded combat, the physiological response to adrenaline and oxygen debt that every fighter pilot learned to manage through training and experience. But beneath the physical reactions lay something deeper, the intellectual satisfaction of a complex problem about to be solved through the application of superior technology and training. The German convoy below represented not just enemy vehicles, but a mathematical equation in which American industrial capacity, pilot skill, and tactical innovation would be tested against German defensive doctrine and battlefield experience. Jug flight will take them in trail formation. 1 and 2 concentrate on fuel trucks at the rear of the column. 3 and 4 work the ammunition trucks forward. Watch for flak positions. Safe altitude is 200 feet AGL until we've suppressed ground fire. The attack began at 08:49 hours, with Lieutenant Morrison diving on the trailing flak half-track, his rockets igniting in sequence with the distinctive whoosh that had become the signature sound of American tactical air power. The first high-velocity aircraft rocket struck the P-47 directly behind the driver's compartment, the warhead detonating against the 20mm ammunition storage. The explosion sent metal fragments and burning cordite in a hemisphere of destruction that eliminated both the vehicle and its crew instantaneously. But Oberst Klug's defensive preparations proved immediately effective. The remaining flak position, a quad-mounted Flak 38 operated by Unteroffizier Klaus Brenner and his three-man crew, opened fire with the mechanical precision that had made German anti-aircraft gunnery legendary throughout the war. Brenner had survived 18 months of combat on the Eastern Front, where Soviet ground attack aircraft had taught him to calculate lead angles, ammunition expenditure, and target priority with mathematical accuracy. The 20mm shells traced bright vectors through the morning air, each round capable of destroying aircraft systems or killing pilots through direct impact or fragmentation damage. Johnson felt his Thunderbolt shudder as 3 rounds struck his port wing, punching holes through aluminum skin and damaging control surfaces. Warning lights illuminated on his instrument panel, hydraulic pressure dropping, elevator response reduced, ammunition feed to his outboard guns interrupted. Jugleader taking damage, continuing attack. The first pass achieved mixed results. One fuel truck erupted in flames that sent black smoke 800 feet into the sky, marking the convoy's position for subsequent attacks. But 2 ammunition trucks had dispersed into adjacent farm courtyards, where hedgerow barriers provided concealment from aerial observation. The surviving flak position continued firing, forcing Johnson's flight to climb back to safe altitude while German convoy personnel implemented well-rehearsed dispersion procedures. Hauptmann Weber, observing from his concealed position, allowed himself a moment of professional satisfaction. American tactical doctrine remains predictable. Single-pass attacks, insufficient coordination between aircraft, inadequate suppression of our defensive positions. The convoy will sustain acceptable losses while continuing mission operations. But Weber's assessment reflected the limitations of traditional military thinking, the assumption that tactical problems could be solved through established procedures, and that enemy capabilities would remain constant throughout an engagement. He failed to recognize that American air operations had evolved beyond fixed doctrinal approaches toward a more flexible methodology that treated each combat situation as a unique engineering challenge, requiring creative solutions. Major Johnson climbed to 1,500 feet, his damaged Thunderbolt responding sluggishly but remaining controllable. Through his radio, he coordinated with the forward air controller and the remaining aircraft in his flight, analyzing the tactical situation with the systematic approach that American pilot training emphasized above all other considerations. Sunray 7, Jugleader. Initial attack partially effective. Enemy flak position remains active. Convoy has dispersed. Request smoke marker on primary target area for follow-up attack. Jugleader, Sunray 7. Understand convoy dispersed. Marking target area with white phosphorus in 30 seconds. Be advised, additional friendly flights inbound from northeast. ETA 5 minutes. The white phosphorus round, fired from a 105mm howitzer positioned 3 kilometers southeast of the target area, burst directly over the German convoy at an altitude of 200 feet. Dense white smoke billowed downward, creating a navigation reference point visible from aircraft altitude, while simultaneously masking German defensive positions from accurate anti-aircraft fire. But more significantly, the smoke marker represented coordination between multiple combat arms that German forces had not anticipated. Artillery forward observers, air-ground liaison officers, fighter-bomber pilots, and ground commanders were operating as components of a unified tactical system that could adapt its methods based on real-time battlefield conditions. Johnson keyed his microphone. Jugflight, revised attack plan, will work the target area in a continuous cycle, maintaining 1 aircraft over target at all times. Suppress flak positions with rocket fire, then concentrate on individual vehicles with machine guns. Use the smoke for concealment during final approach. The second attack commenced at 0854 hours with a tactical sophistication that reflected 18 months of operational experience and systematic analysis of combat effectiveness. Morrison and Lieutenant James Patterson attacked the remaining flak position from perpendicular angles, forcing the German crew to divide their defensive fire between multiple threats. Morrison's rockets disabled the Flak 38's traversal mechanism, while Patterson's 50 caliber machine gun fire killed 2 crew members and ignited ammunition storage. With air defenses neutralized, the American fighter bombers could operate at altitudes that enabled precision attacks against individual vehicles. Johnson dove through the white phosphorus smoke emerging at 150 feet altitude directly above an Opal Blitz, loaded with 150mm artillery shells. His rockets fired in sequence, left-wing pylon, right-wing pylon, each projectile guided by accumulated experience in calculating ballistic trajectories, wind correction, and target motion. The first rocket missed by 15 feet, its warhead exploding against a stone wall and sending fragments through the truck's cargo compartment. The second rocket struck the vehicle's fuel tank, igniting gasoline that spread across wooden ammunition crates treated with preservative chemical. Within seconds, the truck became a fireball that detonated artillery shells in a chain reaction visible from reconnaissance aircraft operating at 10,000 feet altitude. But the most significant development occurred at 0857 hours, when Major William Curtis arrived over the target area with the second flight of P-47s from the 63rd Fighter Squadron. Curtis commanded 4 aircraft, each loaded with 2 500-pound general-purpose bombs, equipped with instantaneous fuse settings designed for maximum fragmentation effect against soft-skinned vehicles. The tactical situation had evolved beyond a simple convoy attack. German forces faced a sustained air operation employing multiple aircraft coordinated with ground-based artillery, executed by pilots trained in adaptive tactical methods that could respond to changing battlefield conditions. Oberst Klug's static defensive doctrine, successful against the predictable attack patterns of earlier air operations, proved inadequate against an enemy that treated each engagement as an engineering problem requiring innovative solutions. Curtis established a holding pattern at 2,000 feet altitude, while Johnson's flight completed their attacks against dispersed convoy elements. Through radio coordination, the 2 flight leaders divided target responsibilities based on aircraft ordnance loads, fuel consumption, and damage assessment from forward air controllers. The 8 P-47s operated as components of a tactical system that maximized each aircraft's capability while maintaining continuous pressure against German defensive positions. Sunray 7, Rebel Leader, flight of 4 with heavy ordnance, ready for target assignment. Rebel Leader, Sunray 7. Primary targets are ammunition trucks in dispersed positions northeast and northwest of smoke mark. Secondary targets include fuel vehicles and transport. Flak positions have been neutralized, cleared for immediate attack. Curtis acknowledged and began his descent, throttling back to control airspeed while maintaining sufficient power for rapid evasive maneuvering if necessary. The 500-pound bombs required precise delivery to achieve maximum effectiveness against scattered targets, but the elimination of anti-aircraft fire allowed Curtis to attack from altitudes that ensured accuracy. His first bomb struck an abandoned Mercedes-Benz fuel truck that German personnel had concealed behind a stone barn, the explosion demolishing both the vehicle and the building while igniting spilled gasoline that spread across adjacent farm buildings. The second bomb landed amid a cluster of 3 Opel Blitz trucks, whose crews had sought concealment in a small grove of apple trees. The detonation killed 11 German soldiers and destroyed ammunition supplies intended for 2 artillery batteries. But more importantly, it demonstrated American capability to locate and attack dispersed targets with precision that exceeded German assumptions about tactical air power. By 0902 hours, Convoy Margareta had ceased to exist as an organized military unit. 14 vehicles had been reduced to 6 burning wrecks and 8 abandoned chassis. 2 flak crews were dead, their weapons destroyed. 43 German military personnel had become casualties, including Oberst Klug, who died when fragments from Curtis's second bomb penetrated the command vehicle where he had established his observation post. But the tactical significance extended beyond the immediate destruction of vehicles and personnel. German logistics operations throughout the Normandy sector depended on precise scheduling that coordinated transport movements with fuel supplies, ammunition distribution, and defensive preparations. The elimination of Convoy Margaret created cascading disruptions that affected 15 artillery batteries, delaying planned fire missions that were intended to support German infantry positions facing American ground attacks scheduled for 1100 hours. Hauptmann Weber, traumatized by the death of his commanding officer and the destruction of his convoy, spent 43 minutes concealed in a drainage ditch before German recovery teams located. His subsequent report to division headquarters provided the first operational analysis from German forces that acknowledged American tactical air power as a strategic threat, requiring fundamental changes in logistics doctrine. Enemy fighter-bomber operations demonstrate coordination and flexibility that exceed previous assessments, Weber wrote in his after-action report dated July 26, 1940. American pilots execute sustained attacks employing multiple aircraft types with precision that suggests real-time intelligence coordination. Traditional convoy defense measures prove inadequate against enemy tactics that combine suppression of defensive positions with systematic destruction of individual vehicles. Recommend immediate revision of supply movement procedures to emphasize night operation and maximum dispersion of transport elements. But Weber's recommendations arrived too late to affect German operation in Normandy. Similar convoy attacks occurred throughout the sector between July 20 and August 15, with American and British tactical air forces destroying over 800 German vehicles and killing more than 3,000 personnel involved in logistics operations. The systematic interdiction of supply movements created ammunition shortage, fuel constraints, and transportation disruptions that prevented German forces from establishing the defensive positions necessary to contain the Allied breakout from the Normandy beachhead. The success of these tactical air operations reflected a fundamental transformation in American military capability that had occurred during 18 months of continuous combat. Industrial production, pilot training, aircraft design, tactical doctrine, and inter-service coordination had evolved into an integrated system that could generate overwhelming combat power through the systematic application of technological and organizational advantages. Republic Aircraft Corporation had produced over 15,000 P-47 Thunderbolts by August 1944, with manufacturing rates exceeding 300 aircraft per month. Each aircraft incorporated engineering improvements derived from combat experience reports, pilot recommendations, and systematic analysis of battle damage patterns. The latest production models carried upgraded engines, improved armor protection, enhanced radio equipment, and more effective armament systems. But aircraft production represented only one component of American air power development. Pilot training programs at air bases throughout the continental United States were graduating over 2,000 fighter pilots per month, each receiving over 200 hours of flight instruction in increasingly sophisticated aircraft. Training curricula emphasized tactical flexibility, air-ground coordination, and adaptive problem-solving methods that enabled pilots to respond effectively to unpredictable combat situations. Equally important was the development of logistics and maintenance systems that sustained high operational tempo under combat conditions. American air units in the European theatre of operations maintained aircraft availability rates exceeding 80% through systematic supply chain management, preventive maintenance procedures, and rapid replacement of battle-damaged aircraft. German forces, constrained by fuel shortages, spare parts limitations, and transportation disruptions, struggled to maintain operational aircraft at 50% availability. The tactical evolution of close air support operations represented perhaps the most significant development in American air power capability. Forward air controllers, equipped with radio communications and detailed intelligence, could coordinate fighter-bomber attacks with ground operations in real time, eliminating the delays and communication failures that had characterized earlier joint operations. Pilots received extensive training in air-ground coordination, target identification, and tactical communication procedures that enabled them to integrate seamlessly with ground commanders during complex operations. This systematic development of air power capabilities reflected broader American approaches to military problem-solving that emphasized technological innovation, industrial production, and organizational efficiency. American military doctrine treated warfare as an engineering challenge, requiring the optimization of available resources through systematic analysis and continuous improvement of operational methods. German commanders, trained in traditional military concepts that emphasized individual heroism, tactical brilliance, and command initiative, struggled to adapt to warfare that had become an industrial process requiring systematic coordination between multiple combat arms. The destruction of Convoy Margarete represented not just the elimination of 14 transport vehicles, but the failure of military doctrine that had not adapted to technological and organizational changes in warfare. The psychological impact of sustained tactical air attacks extended beyond immediate physical destruction to affect German morale, unit cohesion, and command confidence. Soldiers who had survived infantry combat, artillery bombardments, and tank engagements discovered that American air power could locate and destroy them with precision that seemed to transcend normal military capability. The constant threat of air attack forced German forces to restrict movement to nighttime hours, to disperse their defensive positions, and to operate under conditions of perpetual vulnerability that degraded combat effectiveness. But American tactical air operations also demonstrated limitations that German forces might have exploited through adaptive defensive measures. P-47 attacks required favorable weather conditions, with cloud ceilings above 500 feet and visibility exceeding 2 miles. Sophisticated air defense systems, employing radar-directed weapons and coordinated fighter operations, could inflict significant losses on attacking aircraft. Most importantly, tactical air power remained dependent on ground-based forward air controllers and communication systems that were vulnerable to counterattack. German forces possessed both the technological capability and tactical experience necessary to develop effective countermeasures against American close air support operations. The Luftwaffe had developed night fighters, radar-controlled anti-aircraft weapons, and coordinated air defense systems that had proven effective against Allied strategic bombing operations. German industry continued producing advanced aircraft design, including jet-powered fighters that could achieve performance superior to any Allied aircraft. The failure of German forces to implement effective countermeasures against American tactical air power reflected broader systemic problems in German war production, resource allocation, and strategic planning. By July 1944, German industry was allocating maximum production capacity to defensive operations, attempting to counter American strategic bombing while simultaneously supporting ground force facing overwhelming Allied superiority in men and materiel. German commanders faced impossible choice between competing priorities, lacking sufficient resources to maintain effectiveness in all operational areas. More fundamentally, German military doctrine had not adapted to integrated warfare that combined air, ground, and logistics operations into unified tactical systems. German forces continued operating according to traditional concepts that treated different combat arms as separate entities coordinated through higher headquarters rather than integrated components of tactical units. American forces had evolved beyond these limitations through systematic development of joint operational procedures that enabled real-time coordination between pilots, ground commanders, artillery officers, and intelligence personnel. The destruction of German supply convoys by American fighter bombers represented the successful application of industrial and technological advantages through tactical innovation and organizational flexibility. American forces had transformed air power from a strategic concept into a tactical instrument that could influence ground operations with precision and effectiveness that exceeded traditional military capability. Major Johnson returned to his base at A4 Advanced Landing Ground near deux Jumeaux at 09:47 hours, his damaged P-47 requiring immediate maintenance attention, but remaining flyable despite battle damage that would have destroyed less robust aircraft. His written report, filed with the 1999 Tactical Air Command Intelligence Section, provided detailed analysis of enemy defensive measures, convoy organization, and the effectiveness of coordinated attacks employing multiple aircraft with different ordnance loads. Enemy convoy employed standard defensive measures including flak positions and dispersed movement, Johnson wrote. Initial attacks achieved partial success, but required follow-up operations to achieve complete target destruction. Coordination with forward air controllers and artillery support proved essential for locating dispersed targets and marking target areas for subsequent attacks. Recommend continued development of coordinated attack procedures, employing multiple flights with diverse ordnance loads. Johnson's report joined hundreds of similar documents that American intelligence personnel analyzed to identify patterns in German defensive operations, assess the effectiveness of different attack methods, and develop improved tactical procedures for future operations. This systematic approach to combat analysis enabled American forces to continuously refine their methods based on operational experience, maintaining tactical advantage through adaptive innovation. By August 15, 1944, German forces in Normandy faced logistical collapse that prevented effective resistance to Allied ground operations. Supply convoys could not operate during daylight hours. Ammunition shortages forced artillery units to restrict fire missions. Fuel constraints limited armored operation. Communication disruptions prevented coordination between defensive positions. The tactical air campaign against German logistics had achieved strategic effects that exceeded the immediate destruction of vehicles and personnel. American air power had severed the connection between German industrial production and frontline combat units, creating conditions that made continued resistance impossible, despite the continued availability of weapons, equipment, and trained personnel in rear areas. German commanders who had initially dismissed American fighter bombers as flying refrigerators now faced the reality that their armies were being systematically dismantled by tactical air operations that combined precision, persistence, and overwhelming material superiority. The arrogance that had characterized German assessment of American military capability had been replaced by grudging respect for organizational and technological achievements that exceeded German assumptions about democratic societies' capacity for sustained warfare. Oberst Wilhelm Hoffmann of the 21st Panzer Division Supply Section, writing in his personal diary on August 12, 1944, captured the psychological transformation that tactical air operations had imposed on German forces. "We have learned to fear the sound of aircraft engines, as our enemies once feared the sound of our tanks. The Americans have turned the sky into artillery that never stops firing, never runs out of ammunition, never misses its target. Our soldiers hide like rabbits when they hear the distant rumble of approaching aircraft, knowing that death arrives from above with mechanical precision that human courage cannot deflect." The success of American tactical air operations in Normandy established precedents that would influence air power doctrine for decades after the war's end. Close air support evolved from experimental operations into standardized procedures that integrated air and ground operations into unified tactical systems. Forward air controllers became essential components of ground units. Pilot training programs incorporated extensive instruction in air-ground coordination methods. More broadly, the Normandy Tactical Air Campaign demonstrated that warfare had evolved beyond traditional concepts of separate service operations toward integrated systems that could generate overwhelming combat power through coordination between multiple combat arms. Airfields, maintenance facilities, supply system, training program, intelligence organizations, and command structures had become components of industrial warfare that treated military operations as engineering challenges requiring systematic solutions. This transformation reflected fundamental changes in the relationship between technology, organization, and military effectiveness that had characterized American war production throughout World War II. Industrial capacity, scientific innovation, systematic training, and organizational efficiency had combined to create military capabilities that exceeded what traditional military doctrine suggested was possible for democratic societies engaged in sustained warfare against totalitarian opponents. The destruction of German supply convoys by American fighter bombers represented not just tactical victory, but institutional success that demonstrated democracy's capacity to organize, innovate, and execute military operations with effectiveness that surprised both enemies and allies. American forces had proven that democratic societies could develop military capabilities that exceeded authoritarian opponents through superior organization, technological innovation, and systematic development of human resources. On August 25, 1944, the last German forces withdrew from Normandy, ending a campaign that had cost them over 200,000 casualties, 1,200 tanks, and countless vehicles destroyed by tactical air operations. American losses included fewer than 20,000 casualties and approximately 300 aircraft, most of which had been replaced within weeks through continued production and pilot training programs. The statistical comparison reveals the industrial and organizational advantages that had enabled American forces to achieve decisive victory despite facing experienced German opponents, fighting on prepared defensive positions with sophisticated weapons and proven tactical doctrine. American success reflected not individual heroism or tactical brilliance, but systematic application of technological and organizational capabilities that transformed warfare into an industrial process favoring societies with superior productive capacity and organizational flexibility. As twilight settled over the Norman countryside on that August evening, the wreckage of hundreds of German vehicles remained scattered along roads that had once carried supplies to defend Hitler's fortress Europe. The blackened chassis and twisted metal stood as monuments to the power of industrial warfare, to the triumph of systematic organization over individual courage, to the victory of democratic society's capacity for innovation and adaptation over authoritarian doctrine that had failed to evolve with changing technological reality. The P-47 Thunderbolt had begun the war as an interceptor designed to escort bombers at high altitude. Through systematic development of tactics, training, and technology, it had evolved into a precision instrument of destruction that could eliminate individual vehicles with accuracy that rendered traditional military doctrine obsolete. This transformation reflected broader American achievements in developing military capabilities through industrial organization, technological innovation, and systematic optimization of available resources. German generals who had mocked American fighter pilots as amateurs flying crude machines learned too late that warfare had become an industrial process, requiring capabilities that authoritarian societies, despite their military traditions and technological achievement, could not match against democratic opponents with superior organization and unlimited industrial capacity. The laughter had stopped. The sky belonged to America. But perhaps the most profound lesson of the tactical air campaign in Normandy was not technological or organizational, but moral. American forces had demonstrated that democratic societies, when threatened, could organize themselves for warfare with effectiveness that exceeded authoritarian opponents while maintaining the values and institutions that made their societies worth defending. The young men who flew P-47 Thunderbolts over France had proven that freedom could generate military power that dictatorship could not match. As we reflect on these events 8 decades later, we must remember that the victory achieved by American tactical air power in Normandy was not inevitable, was not easy, and was not accomplished without tremendous sacrifice by men who chose to risk everything in defense of principles that transcended national boundaries. Their achievement reminds us that technological capability without moral purpose remains meaningless, that organizational efficiency without democratic values becomes tyranny, and that military victory without commitment to human dignity creates no lasting peace. The story of the P-47 Thunderbolt and its transformation from scorned interceptor to master of the tactical battlefield challenges us to consider what we would sacrifice to preserve the freedoms that those young pilots fought to protect. Their legacy demands that we remember not just their tactical achievements, but their commitment to ideals that made their sacrifices meaningful and their victory worth the price they paid. Do we possess the same commitment to democratic values that enabled their generation to achieve victory against seemingly impossible odds? Are we prepared to make the sacrifices necessary to preserve the institutions and freedoms that they defended with their lives? If their story moves you, if their sacrifice inspires you, if their achievement reminds you of what democratic societies can accomplish when faced with existential threats, then share this video with others who need to remember that freedom is never free, that democracy requires constant vigilance, and that each generation must prove worthy of the sacrifices made by those who can. Subscribe to honor those who gave everything to keep their memory alive, and ensure that future generations understand the price of the freedoms we too often take for granted.